Do you own a codebook? The importance of owning a codebook for electrical work cannot be overstated. It is absolutely essential for anyone involved in electrical installations, maintenance, or inspection. A codebook, such as the National Electrical Code, commonly referred to as the NEC, contains a comprehensive set of standards and guidelines designed to ensure electrical safety and proper installation practices. These codes are developed and updated regularly by organizations such as the National Fire Protection Association, known as the NFPA, to reflect the latest advancements in electrical technology and to address emerging safety concerns. Firstly, consider the safety implications. Electrical work inherently involves risks, including the potential for electric shock, fires, and equipment damage. Adhering to the guidelines outlined in a codebook significantly reduces these risks by providing detailed instructions on proper wiring methods, grounding techniques, overcurrent protection, and other critical safety measures. Without a codebook, one might rely on outdated or incomplete information, leading to potentially dangerous installations. Secondly, compliance with regulations is paramount. Most jurisdictions, including states, counties, and municipalities, adopt electrical codes as part of their building regulations. These regulations mandate that all electrical work must comply with the applicable code requirements. Failure to comply with these regulations can result in fines, project delays, and even legal liabilities. A codebook serves as the definitive reference for understanding and meeting these regulatory requirements. It provides clear and concise explanations of the code provisions, helping electricians and inspectors ensure that their work meets the required standards. Thirdly, a codebook provides detailed guidance on specific electrical installations. For example, the NEC contains specific requirements for wiring residential buildings, commercial buildings, industrial facilities, and other types of structures. These requirements address a wide range of issues, including the type and size of conductors to use, the spacing of receptacles, the installation of lighting fixtures, and the grounding of electrical equipment. A codebook also provides guidance on the selection and installation of electrical components such as circuit breakers, transformers, and motors. It specifies the performance characteristics and safety features that these components must meet to be approved for use in electrical systems. Fourthly, codebooks are updated regularly to reflect changes in technology and best practices. The electrical industry is constantly evolving, with new products, materials, and installation techniques being developed all the time. Codebooks are revised periodically to incorporate these changes, ensuring that electrical professionals have access to the most up-to-date information. For example, the NEC is typically updated every 3 years, with each new edition incorporating hundreds of changes and revisions. Staying current with the latest edition of the codebook is essential for ensuring that electrical work is performed safely and in compliance with the latest standards. Fifthly, consider the role of codebooks in professional development. Electrical professionals are expected to maintain a high level of competence and expertise. Studying and understanding a codebook is an important part of this professional development. It helps electricians and inspectors stay informed about the latest changes in the industry and to improve their understanding of electrical theory and practice. Many electrical apprenticeship programs and licensing exams require a thorough knowledge of the codebook. Sixthly, codebooks are essential for troubleshooting electrical problems. When electrical systems malfunction, it is important to be able to diagnose the problem quickly and accurately. A codebook can be a valuable resource for troubleshooting, providing information on common electrical problems and their solutions. It can also help electricians identify potential code violations that may be contributing to the problem. For example, if a circuit breaker is tripping frequently, the codebook can provide guidance on how to determine the cause of the overload and how to correct it. Seventhly, a codebook provides detailed information on grounding and bonding. Grounding and bonding are critical safety measures that are designed to protect people from electric shock and to prevent equipment damage. A codebook specifies the requirements for grounding and bonding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal enclosures. Proper grounding and bonding are essential for ensuring the safe and reliable operation of electrical systems. Eighthly, consider the overcurrent protection requirements outlined in a code book. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. A codebook specifies the requirements for overcurrent protection, including the size and type of overcurrent devices to use, the location of overcurrent devices, and the methods for coordinating overcurrent devices. Proper overcurrent protection is essential for preventing electrical fires and equipment damage. Ninthly, a codebook provides guidance on wiring methods. Wiring methods refer to the techniques and materials used to install electrical conductors. A codebook specifies the permissible wiring methods for different types of installations, including the type of conduit to use, the spacing of conductors, and the methods for supporting conductors. Proper wiring methods are essential for ensuring the safe and reliable operation of electrical systems. Tenthly, codebooks include tables and examples to aid in understanding. These tables provide information on conductor ampacity, conduit fill, voltage drop, and other important electrical parameters. The examples illustrate how to apply the code provisions to specific situations. These tables and examples can be invaluable resources for electrical professionals who are trying to understand and apply the code. Imagine working on a residential wiring project and needing to determine the correct size of the conductor for a 20-amp circuit. The codebook provides tables that list the ampacity of different sizes of conductors, allowing one to quickly determine the appropriate conductor size for the circuit. Similarly, if one is installing a new electrical panel, the codebook provides guidance on the proper grounding and bonding requirements for the panel. These requirements include the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding the panel enclosure. Let's discuss some specific examples of how a codebook can be used in electrical work. Firstly, consider a situation where you are installing a new lighting fixture in a residential building. The codebook specifies the requirements for installing lighting fixtures, including the type of wiring method to use, the spacing of the fixture from combustible materials, and the grounding requirements for the fixture. Secondly, suppose you are troubleshooting a problem with a motor in an industrial facility. The codebook provides guidance on how to troubleshoot motor problems, including how to check the motor windings for shorts or opens, how to test the motor controller, and how to ensure that the motor is properly grounded. Thirdly, imagine that you are inspecting a new electrical installation in a commercial building. The codebook provides a checklist of items to inspect, including the wiring methods, the grounding system, the overcurrent protection, and the lighting fixtures. The checklist can help you ensure that the installation meets all of the applicable code requirements. Furthermore, a codebook provides valuable information on specific electrical equipment, such as transformers. For example, it specifies the requirements for installing transformers, including the type of enclosure to use, the ventilation requirements, and the overcurrent protection requirements. It also provides guidance on how to select the appropriate transformer size for a given application. For instance, if you are installing a transformer to supply power to a new piece of equipment, the codebook can help you determine the correct transformer voltage and amperage rating for the equipment. In addition to transformers, codebooks also cover other types of electrical equipment, such as generators. For example, they specify the requirements for installing generators, including the type of transfer switch to use, the grounding requirements, and the ventilation requirements. They also provide guidance on how to select the appropriate generator size for a given application. Therefore, if you are installing a generator to provide backup power to a building, the codebook can help you determine the correct generator voltage and amperage rating for the building. Moreover, codebooks address specific types of occupancies, such as healthcare facilities. Electrical systems in healthcare facilities are subject to special requirements due to the sensitive nature of the equipment and the vulnerability of patients. A codebook specifies these special requirements, including the requirements for essential electrical systems, the requirements for grounding and bonding, and the requirements for isolated power systems. Thus, if you are working on an electrical project in a healthcare facility, the codebook is essential for ensuring that the installation meets all of the applicable safety standards. Another important aspect of code books is the coverage of hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust are present, creating a risk of explosion or fire. Electrical equipment used in hazardous locations must be specially designed and installed to prevent ignition of these flammable substances. A codebook specifies the requirements for electrical equipment in hazardous locations, including the type of equipment to use, the wiring methods to use, and the grounding requirements. Therefore, if you are working on an electrical project in a hazardous location, the codebook is essential for ensuring that the installation meets all of the applicable safety standards. In addition to these specific examples, a codebook also provides general guidance on electrical safety. For example, it specifies the requirements for working on energized equipment, the requirements for using personal protective equipment, and the requirements for lockout/tagout procedures. These general safety requirements are essential for preventing electrical accidents and injuries. Therefore, regardless of the type of electrical work you are doing, a codebook is essential for ensuring that you are working safely. The NEC, for instance, covers a wide range of electrical topics, including wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, special conditions, and communication systems. Within each of these categories, the NEC provides detailed requirements for specific types of installations and equipment. For example, under wiring and protection, the NEC addresses topics such as overcurrent protection, grounding and bonding, and surge protection. Under wiring methods and materials, the NEC addresses topics such as conduit, cable, and conductors. Under equipment for general use, the NEC addresses topics such as switches, receptacles, and lighting fixtures. Under special occupancies, the NEC addresses topics such as healthcare facilities, hazardous locations, and swimming pools. Under special equipment, the NEC addresses topics such as electric signs, elevators, and welders. Under special conditions, the NEC addresses topics such as emergency systems, standby power systems, and fire alarm systems. And under communication systems, the NEC addresses topics such as telephone systems, data networks, and cable television systems. Each of these sections of the NEC contains detailed requirements that must be followed to ensure electrical safety and compliance. Another important aspect of codebooks is that they are often used as a basis for electrical inspections. Electrical inspectors are responsible for ensuring that electrical installations meet the requirements of the applicable code. During an inspection, the inspector will typically review the plans for the installation, examine the wiring and equipment, and test the system to ensure that it is functioning properly. If the inspector finds any code violations, they will typically issue a notice of violation, which requires the electrician to correct the problem. A codebook is an essential tool for electrical inspectors, as it provides them with the information they need to determine whether an installation meets the code requirements. Electrical codes also address the use of renewable energy sources, such as solar photovoltaic systems and wind turbines. These systems are becoming increasingly popular as a way to reduce reliance on fossil fuels and to generate clean energy. A codebook specifies the requirements for installing renewable energy systems, including the type of equipment to use, the wiring methods to use, and the grounding requirements. Therefore, if you are installing a renewable energy system, the codebook is essential for ensuring that the installation meets all of the applicable safety standards. Furthermore, the NEC also covers low-voltage systems, which are electrical systems that operate at less than 50 volts. Low-voltage systems are commonly used for applications such as landscape lighting, security systems, and control circuits. A codebook specifies the requirements for low-voltage systems, including the type of wiring to use, the overcurrent protection requirements, and the grounding requirements. Therefore, if you are installing a low-voltage system, the codebook is essential for ensuring that the installation meets all of the applicable safety standards. In addition to the NEC, there are other electrical codes and standards that may be applicable to specific types of installations. For example, the National Electrical Safety Code, or NESC, covers the installation and maintenance of electrical power and communication lines. The NESC is used by utilities and other companies that own or operate electrical infrastructure. There are also industry-specific standards that may be applicable to specific types of equipment or installations. For example, the standards developed by Underwriters Laboratories or all cover the safety of electrical products. These standards are used by manufacturers to ensure that their products meet the applicable safety requirements. Remember, electrical codes are not just a set of rules to follow, they are a set of guidelines designed to protect people and property from the hazards of electricity. By following the code, you can help ensure that your electrical work is safe and compliant. Therefore, investing in a current edition of a relevant codebook is an investment in safety and professionalism. It is a resource that should be consulted regularly and kept readily accessible on any electrical job site. Owning and understanding a codebook is not merely a suggestion, it is a necessity for anyone involved in the electrical industry. In Illinois, adherence to these codes is crucial for safety and legal compliance.